All right, last week we were talking about adding, subtracting, and we did some multiplying with polynomials. This week we're going to be factoring. So just kind of a quick review over your factoring rules. First thing, always look for that common monomial factor. Then you can look for patterns. I forgot to write that down, but if it's a pattern, something you recognize, you can use the pattern to factor it. And then if it is three terms, okay, maybe I should put that in parentheses. Three terms, you're going to be thinking about a product sum table. Okay, if A is 1, then once you do your product sum table, you've got your numbers you can factor. If A is not equal to 1, you have like a 2x squared, then you're going to need to do your product sum table, but you'll have to follow it with a box. Okay, then the next thing in this piece is kind of new. What if I have more than 3 terms? What if I have 4 terms? Okay, so if I have 4 terms, you're going to go to a box, okay, and then I'll show you how that works. Okay, so these first couple factor each completely. So again, we're going to look for that common monomial factor. This one has an x that can be factored out. So we're going to take out an x, and there you go. All right, then it's a trinomial. So I'm going to do product sum table. So multiply to get 10, add to get -7. So that's going to be a -5 and a -2. So since my a is 1, it's just a 1x squared, I can go straight to my factored version of x times x minus 5 times the quantity x minus 2. Okay, for 19, again, common monomial. So we've got variable y's and 3. I can take a 3 out of 75. So I'm going to factor out 3y cubed. I would have a y squared minus 25 left over. Okay, now y squared minus 25. Well, you might recognize that as a difference of square pattern. So if you do, you can factor that, y minus 5 and y plus 5. If you don't recognize that as a perfect square pattern, multiply to get -25, add to get 0, and then there's your -5 and +5. Okay, if we look at these patterns, these over here on the left are some patterns that we've used before. That first one actually popped up with this y squared minus 25, so that was that difference of squares pattern. Okay, new ones. These two here are new ones. These are the sum of cubes and difference of cubes. So same thing, sum is add, two things added together that are cubes, or subtracted that are cubes. Okay, and these next two examples are going to look at that. Okay, so the first tip off that we might be a difference of cubes, notice there's 2 terms. Your subtract, so difference, and this first term here is definitely cubed. It's w cubed. Okay, so the question is 27 something cubed? All right, well, 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, and 5 cubed is 125. Okay, so those are all perfect cubes. So it's kind of worth having an idea of what those numbers are, being a little bit familiar with those numbers. So you'll notice that 3 cubed gives you 27. So 27 is a perfect cube. So it does fit the a cubed minus b cubed pattern. So what we're going to do is we're just going to follow the pattern. Okay, so all I've done here is I have just transferred this difference of cubes pattern. Okay, so now I'm going to figure out what my A is and what my B is, and then I'm just going to follow the pattern. So everywhere I see an A, I'm going to put that number in, and everywhere I see a B, I'm going to put that number in. Okay, so go back to our w cubed minus 27. So here, this A, what's being cubed? A w is. Okay, then what's being cubed to make a 27 is a 3. A 3 is being cubed. Okay, so now everywhere in my pattern where I see an A, I'm going to put in a W. Okay, because it follows this A cubed minus B cubed. It's W cubed minus a 3 that's being cubed. All right, so A is W minus the B is 3. Then A squared. Okay, well, my A is a W, so I'm going to go W squared plus, now this time do A times B. So you're doing W times 3 or 3W plus B squared. So 3 squared is 9. Okay, and that is how you use that difference of cubes pattern. So this is factored. So if you wanted to, we could take time and distribute, okay, the W through, go back at the 3, distribute it through, and once we multiply and simplify, it will take us back to this W cubed minus 27. Okay, now this second piece is a quadratic, but it will not factor. If you try to do a product sum table, it won't work. Okay, so no point in trying that. And that's true every single time. So once you've applied the difference of cubes or sum of cubes pattern, then that is all that you're going to be able to do with factoring. Okay, so 21 is another, it's going to be a sum of cubes problem. But if you notice with this one, you've got some common monomials. So I have a B squared in both of them. And 16 and 686, they're both even. So that means I'm going to be able to factor out a 2. So I'm going to take out 2b squared, and let's see what's left. So 8b cubed plus 343. Okay, so now the first question is this going to be a sum of cubes pattern? It's plus, so it's going to be sum. Well, this b is being cubed, so that's obvious. Look at the 8. Well, if you go back over here to where we listed out some of our perfect cubes, you'll notice that 2 cubed is 8. Okay, so yes, so that is something cubed. Oh, wait, you know what? Before we go any further, let's change these variables to x's, okay? I think that'll just be easier to keep track of. So let's make these x's instead of b's. I think that will be easier. And I just rewrote the same thing I said I didn't want. Okay, one more time. So let's make them an x. Okay, good. Now, the x is being cubed. The 8 we figured out is a 2 cubed. So that means what cubed gives you 8x cubed? So 2x. So if I cube that, that gives me the 8x cubed. So that's going to be the A part of my equation. Okay, now, if you look at our list, oh, now it doesn't go as high as 343. So let's try a couple more. If we go 6 to the third power, we get 216. Okay, so let's add that to our list. Okay, so 6 cubed is 216, so still not big enough. Let's check and see what 7 cubed is. So 7 to the third power, there's that 343. Okay, so this 343, well, that's 7 that's being cubed. So that means the B is going to be the 7. The A is the 2x. Okay, when you use this pattern, now this is a sum of cubes because it's plus, but the pattern is the same as the difference of cubes. There's just a couple of signs that change. So this becomes A plus B instead of A minus B. And then this is A squared minus AB plus B squared. So just a couple of signs trade places, but otherwise it's the same pattern. Okay, so now let's use what we know is A and B and follow this through. So a plus b. So a is 2x plus, what's my b? 7. A squared. Okay, now that's going to be 2x and the whole thing gets squared. Okay, some people forget to square that too. All right, and then minus a times b. Well, a is a 2x and b is a 7. So you're going to multiply those together. So we'll clean that up in a second. And then b squared. Okay, well, b is that 7. So I'm going to go plus 7 squared. Okay, so like I said, let's clean this up. 2x plus 7, and then 4x squared minus 14x plus 49. Okay, and there's that perfect, or a sum of cubes pattern. Okay, you'll have, I don't know, I think about 3 or 4 of those in your homework, so you can practice those patterns. They're a little tricky to grasp hold of. Okay, so what we've done so far is we've just done some basic factoring, okay, kind of a refresher. You now have a difference in sum of cubes pattern that you can follow if your expression is something cubed. Okay, now 22. Well, you'll notice here there's 4 terms. Well, we haven't done anything with 4 terms yet. But if you go back up to my list, number 3, 4 terms, we're going to use a box. Okay, now you could group if you want to. I can show you both ways. I really do like the box for this one. Okay, or for these. So you've got 4 squares in your box. You've got 4 terms. So each term is going to go in a square. Okay, so now you're going to go through, do what you did before when you were factoring in the box. Look across the first row, and they have an x in common. Bottom row, they're both divisible by 9, but actually I'm going to do -9. Pull out that negative. And then look down the first column. They have an x. Oops, I made a mistake. This guy right here should be an x squared. So that means when I pull out an x here, that should be an x squared. Sorry about that. Okay, then look down this first column, and they have 7. 63 is divisible by 7. But look, the first term's negative, so you're going to take out a -7. Okay, so factored here, x squared minus 9 times x minus 7. Okay, and that looks good. Okay, however, remember, I think the directions say factor completely. We're not done yet. Okay, so look at this, x squared minus 9. Hopefully you recognize that as a difference of squares. So that factors to x plus 3, x minus 3, and then my x minus 7 is going to come down, and there is your factored version. Okay, we have a few more